I start to teach symphony. Some of you know it, others know. Symphony, it's like Excel. In a telecommunication company in 1990. In 1992, I started to teach in the university. It's a polytechnical university where I still I started to teach algebra and numerical analysis. One, it's very easy to apply to engineer. I usually to use when I teach in chemical, I use examples from chemical engineer. When I teach in mechanical, I try to find mechanical exercises to apply what I teach. Now I start to teach math calculus. It's the worst course in the high university. Usually the courses where the students have the bad results. Last year I was in Canada and I hear Eric Mazur talking about peer instruction method. And I thought it's very interesting. And I applied this here in calculus. And I have good results. Why I applied this kind of methods? Because learning is not a spectator's sport. Students do not learn much by just sitting in class, listening to their teachers, memorizing or prepackaged assignments and speaking out answers. The teaching learning process has been a constant stage of study, particularly in higher education, in consequence of the annual increases of new students. Consider the particular case of engineer, it has been witnessed a rising concern with active learning strategies and forms of assessment. Research has demonstrated that students learn more if they are actively engaged with materials than are studying. And our studies and the students in our day are different from students I started to teach in 1992. They have more things to do outside the classes. And the last years during second semester, the weather in Portugal are really better than on the past, and the beach is near and very good to be in a cafe or something like that. So we need to try to motivate students to be in our classes. So I'm going to present for people who don't know what is peer instruction methods. I'm going to start to say what is this. And I'm going to present an example of the application of peer instruction methods in a course of moreover than 50 students. And over and a half are repeating. So what is peer instruction methods? Was developed in 1990 at Harvard University by Eric Mazur. The teacher presents students with a quality, usually multi-choice students, that is careful structured to engage students' difficulty with fundamental concepts. After that, the students consider the problem on their own and contribute to their answers in a way that the fraction of classes given each answer and can be determined and reported. After that, the students, the teacher saw how many students have their answers correct or not, and ask them to discuss with their neighbor the results. If the neighbor has the same answer, they ask for the neighbor behind or in front of them. The student, after that, minutes, the students vote again. And when we on second session, we expect the answers are better. This year never happened like that. Sometimes it's the opposite. Hopefully, only 2 or 3 times. After that, I solved the questions at the board. So this is the peer instruction methods. There are a lot of literature in the website if you want to see which kind of application you find it. Yesterday, Peter Goodway presented you a book of Eric Mazur about the conceptual questions by physics are the questions who Eric Mazur made in their classes. The technique I use, which technique? The number of students are 558 students, enrolled in 10 small sections of 50 or 60 students. These small sections were taught by 3 different teachers, not all me. Another thing is important is one of the objectives of this kind of methods are the students need to study at home, and after that the teacher made us a small summary at the beginning of the lesson and start the instruction. I start with 30 minutes with a small summary. Why 30 minutes? Because we have a lot of full students. They work during all day, and at 6 p.m. they start their classes and finish at 11:30. Some of them went to their classes during the morning and work during the afternoon or night. So we have a lot of students who need to work because they have no money to study, only study. At the last 20 minutes, I applied the peer instruction methods. Eric Mazur uses the clickers, some electronic clickers. I have no clickers. We can use different colors of papers, but if I apply that, first day okay, second day they forgot their papers at home. The fingers they bring with them. So I use fingers. 1, 2, 3, 4, or 5. So that's I use their fingers. So this is one of kind of question I put easily, not very complicated. I start with the basic question. Just find the area of this thing. So the people start to answer. The answer is this C. They discuss it. So this is the kind of questions I put to my students. After their first answer, they discuss each other. Here are some of questions they ask to their neighbor. What is your answer? Why? Because they need to convince. I'm correct, you are not. With these questions, I assess whether the students have learned their object. If I have more than 50% of students who in second votation failed, I need to explain better the subject because something is not correct. The assessment results. I have here the results since 2006. The results in 1, 2, 3, 4 in the last 4 years are similar. We are going to focus in the last 2 years. You can see the number of people who quit decrease for about 300 to 180. So this kind of classes motivate the students, and the number of the students who succeed pass to the double, to 150 to 300. So I thought this method not only for these results, but more for the students who didn't quit. Because most of our problems aren't the number of students who failed, are the students who, after 1 or 2 or 3 weeks, give up, they quit. We can't do nothing with kind of students. And I thought these methods could the students that not happen. So this, to me, this is the main my main objective was that, and I did. I did. More results here are from all students, and the students who already failed at least one time or give up in the past. We can see here the last and the number of the succeed students increase a lot, and the number of students who quit decrease. But better of all are the students who are at the first year at first time. The number of students who quit are very low. I could motivate the students from first year. And it's very important, because the students fail in math on the first year, in the second year, or probably they give up, they go to an university, I don't look like engineer, or something like that. So it's very important the students have success as first year. If they succeed in first year, they have no problem in the future. So we need to apply this kind of methods in first year. Assessment results. The assessment results are similar. I have no different from the other years. The assessment, their grades. If we saw the number of the marks are similar. Probably the number of 10, 11, and 12 are students who quit on the past. They study a little bit and they pass this year, but not good marks, but medium marks. These are new students. The number of new students who succeed are really high than the past too. And these are students who failed at least one time. We saw, the number of the students have better. The results are, it's this column are really better if we compare to the past. When every assessment finish, not before, after every assessment finish, I made this inquire, electronic. So it's not the students only answer if they want. And from the about 3 students who attend, 145 answered the question. And 80% said they thought the classes are more interesting and learn more in classes with methods of peer instruction. 9% this doesn't matter, I learn anyways. Only 12% said, I don't understand anyway. So I need to focus with this one now, in the future, next year. So what is this result show? Show that unlike the last 2 years, the students have shown more interesting in class and overall results have dramatically improved. And the enrolling student segment achieved the most noticeable improvement in results. So, thank you very much.